Welcome to the Institute of Technology's next section of this LoRaWAN course. We're going to be covering the Clover sensor, just basic connectivity. We're going to connect it to our AWS IoT Core platform for LoRaWAN. We're going to go through the registration process, configuration profiles, destination rules, and then finally we're going to activate the Clover sensor, show you that process, and try and get an MQTT message from the sensor. Very basic steps in the next section here. It is a fairly long video for this, but we're going to go through each of the steps and what they do in a little bit of detail, so we've got a better understanding of what we're going to do in the next series. Look forward to it. Here we go. Okay, so let's kick this off. We're going to start off opening up your Explorer into AWS. We're going to go into IoT Core, and then from there let's click into the LoRaWAN devices, and under that we're going to go into devices and we're going to add a wireless device. You'll see the category here with a whole lot of different inputs that we have to do. We're going to choose the wireless device specification now with a Tiktaalik, and most of these endpoint sensors we're going to use over the air, and there's two different versions that we use, and with Tiktaalik they generally want you to use the version 1.0x. The other one is the version 1.1, and really what these do is the one offers more security than the other. So with this course and the basic stuff is really the 1.0x, root keys, session keys, roaming, class B, joining procedures, the security and deployment. Security levels are a little bit less stringent as they are with the version 1.1. Less app keys, you know, there's strong separation between the network versus the application. From a security deployment point of view, the version 1.1 is way stronger. So, but for this course, we're going to just stick with the version 1.0x and move it on from here. Right, so we've got to enter the DevEUIs. We'll find all these keys. Tiktaalik, when they sell you sensors, they generally give you an Excel spreadsheet for you to copy and paste all your app keys, AppEUIs and DevEUI keys. So that's what we're currently doing right now. We're going to name this thing, we're going to name it the Clover because that's our first sensor. Descriptions are not important, just as long as you understand what they're for and what they're doing. The additional options in the configuration I'd leave out. Thing association I'd leave out, and then we're going to start on the profiles. Okay, now that we're on the device profile page, we're going to create a device profile. There's a whole lot of categories here that will kick into play. One of them is creating the device name. This label is, we're going to go 915 over the air. It helps you identify the frequency band and the joining method. Doesn't affect the device at all, it's just for the organization. The other one is frequency bandwidth, sorry, the RF region. 915, it's just got to match the device's support band and the gateway's configuration band. Next one is the Mac version. We're going to go 1.02. This is the LoRaWAN MAC layer version. It should exactly match the firmware version of your end device. And then regional parameters version, it's recommended to do the RP002-1.0.1. This ensures the AWS and your device agrees on the channel plans and timing. Next is the max ERRP. This is the maximum transmission power that this device will allow us to use. So it's expressed in decibel milliwatts. I think the maximum it will let us set it to is 15. It's going to be 16 or less. Just to give you an idea, 13 decibel milliwatts is about 20 milliwatts. And this is really got to be aligned with the regulation limitations. So the FCC limits within the US and what the device capabilities will allow us to use, right? The supports class B and C and support joins. Those are just, we can leave those out. Those are efficiency downlinks and uplinks. It's just the device always listening, it uses more power. Those are presets already. We can move on to the next. This section we're going to leave pretty much at default. RX delay 1, it's going to be set at 1 second. It's going to be perfect for terrestrial gateways. Anything longer, you're going to need another network, which is like a satellite LoRaWAN or something like that. RX data rate 2, we'll leave that preset. It ensures a reliable downlink delivery for the RX1 if that fails. DR offset 1, we're going to leave that standard. It's very vendor specific. The RX frequency 2 must align with the LoRaWAN perimeters of your band. Also, the factory presets frequencies are going to be incrementally done by 200 like we did before in the SSH. That can all be left the same. Maximum duty cycles, it's really enforced by the EU 868 regions. It's really not a thing for the 915 band, but you can preset that if you need to. The 32-bit FC NTs, that really helps avoid replay attacks and keep session security strong. It's enabled as yes, that's no problem there. So yeah, I think we're good to click next. Okay, so we're going to now add a service profile. We will click to add service profile, give it a name. We're going to tick the box that's got the gateway metadata on there. This enables AWS to collect extra information from the gateway, attaches it to the uplink packages like the signal strength indicators, signal to noise ratio, gateway geolocations. It's super useful for diagnostics, coverage maps, and network optimization. We're going to leave the ADR, which is adaptive data rate configurations, as they are pretty standard for this video. Those are really helpful for trade-offs between range, reliability, and power consumption. Devices that support the ADRs can automatically adjust the spreading factor, the bandwidth, transmission power. We're going to also leave the data rate range the way it is. This defines the range of the data rate spreading factors the device can use under the ADR control. We've got the data rate minimum and then the maximum, usually it's 0, and maximum is set at 15. The device can shift anywhere between min and maximum depending on the conditions. So yeah, and this section we've got we're also going to keep this defaulted. We've got the transmission power index. LoRaWAN uses power index scales, anything from 0 to 15 to represent different transmission powers. It's measured in decibel milliamps. It's also dependent on the region, so we're 915 US, but generally the lower index is always set at 0 with maximum transmission power, and then the higher index is at 15 with the minimum transmit power. AWS uses this range to let the ADR, the adaptive data rate, dynamically adjust the power. And yeah, so 0 to 15 lets the ADR use its full range, and if you want to say battery, you could restrict it to 3 to 10 but this may hurt the coverage. The next thing we're going to look at is the number of transmissions, the nbTransMin and the nbTransMax. This defines how many times the device is allowed to retransmit the same uplink message. Useful if the packet loss is expected, if there's weak coverage or noisy RF environment. There are a few trade-offs. The more retransmissions, the more reliable, but the higher the airtime, it charges a lot of battery and potential network congestion. But you do fewer retransmissions, it's more efficient, but the message may get lost in a poor RF condition. So you just got to watch out for that, but we're going to keep these at the default settings. The public network, we're not going to check this box. This is if you do select it, it's your device is connected to EveryNet's public LoRaWAN network, which is cool if you don't want to deploy your own private gateways. This is useful if you don't want to manage hardware and you want to backup coverage in areas where your gateway might not always reach. It's operated by EveryNet, so not AWS directly. And if you want your private network, if it for whatever reason it goes down, EveryNet can still provide the coverage. So if you're deploying it in a city where EveryNet has coverage, you can connect without setting up a gateway. And if you're on a farm or a sailboat with no EveryNet coverage, you rely on your own private gateway instead. So we're not going to do that right now. We're not going to tick that box. Additional tags are metadata. You assign AWS resources and the key values like environment equals production, project equals LoRaWAN demo, owner equals me, Jared. Benefits are searching the filters, resources. It enables cost allocation reports, like track LoRaWAN costs and projects, departments. It's useful for automation. So it's basically additional labels to help organize, track, and manage your LoRaWAN resources. But we're going to leave that for now. So let's button this service profile up and add it. Okay, so now that we have created those profiles, let's allocate them. We just use the drop down here under wireless device profile and service profile, and then we've got an option just below here that's tags. Right, the tags are metadata you can assign to AWS resource, right? So each tag has a value, and the benefits are it's easier to search filter devices in an AWS console. It helps with cost allocation reports, track costs by project, team, or client. It's useful for automation. You can assign up to 50 tags. We're not going to do that right now. We'll get into all of this when we start really fine-tuning this. But right now we're just wanting to create basic situations. We are going to need to create a destination, which is just under that. It tells AWS where to send the LoRaWAN uplink message that it transmits. So whether it goes to Amazon S3 or DynamoDB, Amazon Timestream or Lambda, this is where the destination has to be allocated and created. So we've got to create a destination, and let's get onto that. Adding a destination type is where the device's uplink messages will be routed. We're going to just do a test name, we're going to do a test description. Out of these two options, we're going to do option A, which is enter the rule name, which we'll specify with an IoT rule. And then when it comes to advanced topic name, we're going to also just do test. This lets us define the MQTT topic name, and the topic will be when the rule is invoked and can be accessed through the IoT rule topic. We're going to just do test name there, and then we've got to actually create a rule, right? We've got to now create the rule. we're going to give it a name, which is just test. We'll give it the description, we're going to leave blank, and then we're going to also just not go into too much detail about all the other features. They're not many, but we're going to configure the SQL statement, and I'm going to type in here select star from IoT, which that means is it's going to take all the attributes that it's pulling from the sensor, and it's going to forward them to an action, which is either to S3 or DynamoDB or whatever. But at this stage of the game, we're just wanting to just pull data, whatever it is, maybe all of it. It's not the best practice when it comes to you're really wanting to hone in on the data and categorize it, but for now let's just see, we'll forward everything, and then going forward we can filter the data when we need it. Okay, so we've now created the SQL, we've configured the statement on the SQL, meaning that we're going to forward all the messages from the topic. We now need to create the rule actions, and there's a drop down here. Does republish to AWS topic, send to Amazon 3, that's for raw storage and decode payloads, insert to DynamoDB, structured, that's for structured data, send to Amazon Timestream, trigger AWS. So we're going to do republish to AWS IoT topic, and this is useful for multiple subscribers to consume the device data, basically like apps or dashboards. It just normalizes the topic for consistency. And then we're going to leave the quality of service at 0. It's the fastest, no acknowledgement required. And then we're going to just leave the QoS that defines the reliability of republishing. So under MQTT5 we're going to just leave that as it is. This basically is just an attachment for extra metadata. Doesn't change anything with regards to the payload. It's just that the subscriber can use it for filtering and routing options. The user properties, we're going to leave it also for now. Similar to MQTT5 properties, but a little bit more flexible. Just you can use it if you want to carry out application specific tags with the messages. We're going to use an IAM role, but we're going to use just an existing permission layer here. AWS IoT needs the role to execute the action, whichever one we choose. It just gives it the permissions it needs. If we're invoking Lambda, it needs a Lambda permission or whatever else we need. And we get to the next. Okay, coming close to the end of our rule creation, we're just going to leave everything as it is. We're going to click next. Scroll down. This is just a summary of a review, and then let's create this. There it's active, that rule, and we can move on to the next section. Right, now that the rules have been created, we're going to shift over to a more practical setup, which is we are going to read this documentation that's on the board right now, and we're going to do the activation of this device. Now the device, you're going to need quite a high powered magnet and the actual sensor, and what we're going to do is we're going to put the sensor onto the magnet like that, and we're going to start to count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that you'll see some LEDs blinking, and we now know that we're online. But we're going to shift over. Right, so let's navigate back to our AWS. Let's go to our devices, and under the devices page we are going to see the destination that we just created prior to setting up. It's going to ask us a few questions which we're going to leave out, but this is generally for AWS to, you can attach a location to the device. So if you're wanting to find it in a big agricultural field, you can find it. You can also do additional geolocations. This is quite handy, but can cost a little bit more. You can, if you enable this feature, it will determine the device's location dynamically. It usually uses a network triangulation or GNSS module, and that's quite handy to use. We're not going to use or put any inputs down under this section. We're just going to add device. From adding the device, we'll see all our LoRaWAN devices here. This is one they've just created. We're really looking at where it says last uplink received. There's nothing there, so what we're going to have to do is we just make sure that the gateway is on, it's blinking, green blinking, the device is on, it's blinking green as well, and what we've got to do is we're just going to try and activate this so that it can send an uplink to this, so we can actually physically see it working. From here we're going to go back to the magnet and just apply it for maybe 3 or 4 seconds, and this is so that it can join the network, the gateway, and it'll rejoin the gateway, or it'll be its first time joining the gateway. So when we finish with that, we go navigate ourselves back to the devices on AWS, and then we're gonna, you'll see where it last uplink, that's where it's joined. So we've got some communication going through there, and it's showing through AWS, which is a really good positive. And then what we're going to do is we're going to navigate ourselves to the MQTT test client, and from there we are going to subscribe to the topic. So I think our topic was test, was the original topic, and then from test we're going to say subscribe, and we're going to wait for a message to come through. Now, instead of holding up for 4 seconds, we're going to hold it up for 2 seconds, otherwise it'll rejoin the gateway again if we do it any longer, and it should give us a message, and we just wait a few seconds, and just like that we've got a message. Congratulations, we've successfully completed the basic setup of the Clover sensor, connecting it to AWS IoT. We've covered the registering of the device, creating profiles, how to set up destinations, some rules, all basic foundational work that will allow us to expand into further advanced details, like integrating databases, dashboards, and analytical tools. So let's move on to the next section where we can dive a little bit deeper into this. Look forward to seeing you there.